Hey guys, welcome back to AlgoYogi, and we are doing binary search series still. Now we are starting the medium category problems. So let's visit our next problem on LeetCode, which is single element in a sorted array. You know, whenever you see a sorted array, just always think about if you can apply a binary search. If it's about finding some index, finding some element, right, finding some value that would do something, and given they're mentioning explicitly that it's a sorted array. So don't just be like, oh, I'm gonna do a linear search for loop, one for loop, big of n time complexity, I'm done. Just always think about bringing the time complexity to, if you can. Yeah, not always. Okay, so you are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. So now we need to return that element that only occurs once. Pretty easy, right? Yes, exactly. If you're doing linear search, that's definitely easy. Start a linear search at index 1 and then keep checking if it is equal to its next element. If it is, then keep checking, and there will be a position where the element will not be equal to its next element, then return the element, right? Make sure that you are checking. You're only going up till the second last element, so that and I plus 1 could be perfectly checked with matches with the last element. But then that will be a big of n time complexity, but we're going to do better than that, which is log n, and space complexity, which is constant. So log n, which is basically that can be achieved by binary search, and we're going to apply that, but it's a little tricky to come up with the solution. How actually do we apply? What's the condition to basically divide that input size to half, right? That's the core of binary search, that in binary search we are able to basically bring the input size to half, and that's how we attain the time complexity. Each time you're calling that a recursive function or some operation. Okay, I don't know why my feet are feeling a little weird. Whoa, what are we talking about? Okay, so here is our array, right? Now if you see 1 occurs twice, 2 occurs only once, so that's our answer. That's easy, right? So linear search, going through, keep checking if it is matches with the next element. It does not, but just remember, I will increment here by 2. Okay, once you start with the first element, so then you start checking this one. This does not match, so okay, get out, return that. So now how do we make sure that we find out this element that only occurs once? So we're gonna use binary search that we talked about, and we're gonna have left and right pointers, which is basically the core steps in binary search solutions. But in this one, when we are finding out mid, so that will be left plus right divided by 2. So in this case, let's write down our indexes, which will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So what we're gonna do is we're gonna find out the mid, which will be 4. 4 is over here. This will be our mid. Now what we want to do is, if this was, sorry, my bad, if this 3 only occurred once, then since it's a sorted array, then its pair will not be on either side if it occurred only once, right? So we're gonna check if this 3 does not occur on left or it does not occur on right, then we just return the answer. So our condition would be if this mid, so I'm gonna say num mid is neither equals to, I'm just gonna write it like this, and nor it's equal to m plus 1. These represent, by the way, this represents the number at those indexes. If none of these satisfies, I'm just gonna also write it here, m is not equal to this. If these two satisfy, that means we found the element that only occurs once. And given we will have these edge cases where what if your mid is pointing to the first index, that means we will have like this little condition over here. If m minus 1 is basically lesser than 0, that means or this particular condition. So either of these can satisfy, because this says that the element before it doesn't exist. That means the element that I'm seeing is, it at least doesn't have anything to the left of it. And same thing we're going to do here, that or m plus 1 is basically if it is greater than or equal to length of the array. So if you're following me, you will understand what I mean here, right? These are two basically going out of bounds. So we're kind of creating like a circuit here, right? We're creating a circuit. If you want me to go in detail, you know what? I'm gonna go in detail, because that's how we learn, right? That's how we learn. So what I meant is, when we have our left pointer, left pointer and right pointer, and we are finding out our mid is through left plus right and divided by 2. So when we are finding out our mid, our condition will be if m minus 1 is lesser than 0, or num m, which is mid, is not equal to nums m minus 1. If this is not the case, that means the element that I'm pointing to, my mid is pointing to, does not matches with the left element that it has, or it might not have because of this. But this will make sure, if this is the condition, we have or statement, so which creates a circuit. If this condition passes, then it will never go to this condition. All right, so this circuits from here, short circuits from here. And then we'll have another condition, that this is not the left is not the only check we are doing. We want to do we want to check the mid element to the m plus 1, mid plus 1 also, so that it can have its second occurrence on the left or right. So that will come over here, which will be the same condition, but except for the other side, next element, that will be m plus 1 is greater than or equal to length of nums. This is one, or nums at mid is not equal to nums at m plus 1, right? So here we have basically these two conditions. So this is 1, this is 2, checking for each side. If both are true, joined by and, then we return that element. Otherwise we keep looking. How do we look? Since it's a binary search, we need to cut down the input size to half of the previous array. All right, so we are using input like the left and right pointers, so we're going to use those pointers to basically decide where to actually look now. So now since you have understood these conditions, so what I'm going to do is I will let me just copy this part. Okay, I'm going to just copy this part and take it below. Okay, I'm going to paste it over here. Right. Okay, so now we're gonna find out how actually we're gonna decide. So since our left is pointing here. Oh my god, left is pointing here, right is pointing here. My mid is basically that we found out by left plus right divided by 2. That is pointing over here at 4. Now we checked that this is actually equal to this. This is not equal to this, but either condition passes. That means we need to now decide either to look in this half, or basically this half. So by the way, this we will eliminate this, by the way, since this is already equal to basically these two values, so these could be eliminated, right? But anyway, like what we really wanna check is now is that if all the elements occurred twice, every element occurred twice, that means we need to have basically even number of elements, right? It should be if all two elements, then occurrences of all the elements would be even. This is what I'm trying to say. But since we know that there is one element that's extra, then, and we just found out, either we just find the answer or we found out that these two do not occur, that mid does not occur. So what we want to do from this point, we are pointing, the mid is pointing over here. So we see which side actually has odd number of elements. So this side, or this side, or this side. So we're gonna check how we're gonna find out that by basically using left count or right count, whatever count you want to find out. First, that will depend on like two conditions, by the way. That will depend on, one of the condition is if this number was equal to the left number or the right number. Let's say if it was equal to the right number, that means we would want to count from m plus 1, okay, m plus 1, which would be over here, these two, the right element. So basically r minus m plus 1, that will be the number of elements. But let's say we're trying to find out on the left side. But it doesn't matter like which side the number was equal to, but we just want to know where it was, how to calculate. And we will definitely have a check if it was equal to left, because we are trying to calculate the left count, and that will happen. So left count would be m minus 1 if this m minus 1 was equals to basically mid, okay, else it will be just m. Since this is not equal to any number, then this is the entire, let's say it was something else, then it will be the entire left count, and this will not be included, because that's where all the even count will be, because at the end of the day we have only one, or every element has a pair, which means it was supposed to be even. Not anymore, because there is only one extra element which only occurs once. Alright, so I think now it will be a big of log n time complexity, and I think we have understood it. We have definitely understood it. I think I tried my best. Alright, yeah, my handwriting is really bad, I'm sorry about that. Was never proud of it. Okay, so we're gonna have left and right pointer pointing to 0 and basically length nums minus 1. Now we're gonna start a while loop. While loop would be left is smaller than or equal to right. That's what most of the conditions in binary search would be. Now let's find out the mid. Mid would be left plus r minus l, half the difference. You know about it, we have already talked about it like a lot of times. So now if we like understood this condition like really in deep, so I'm just going to quickly write, if m minus 1 is lesser than 0 or nums, I'm going to have this condition, nums middle is not equals to, or I'm just going to say equals to, sorry, not equals to, because I'm not checking equality, I'm checking inequality here. So nums m minus 1, that's one condition. If this and this, the next element, it should be, if this is greater than length of the nums, so len nums or equals to, because index starts at 0, and this also needs to be changed. So either of these condition match, not either, actually both of them, but what I mean is like in the brackets, either of these, this will create a short circuit, so this condition will not be checked because of or here. If this is true, then you don't have to check the next statement after the or. So this is where we will return that single time occurred elements, which would be nums at middle. All right. Otherwise, let's find the left count. Left count we can find out. We said it's gonna be m minus 1 if basically nums middle that we just found out, if it is equals to nums minus basically mid minus 1, else it would be just middle. Okay, so this is basically saying that if this mid is pointing to third element, then if that third element was equal to basically second element, so in that case it should be 3 minus 1. Two elements are before that, which would be 0 and 1. Okay, otherwise it would be just m, because this number that we are pointing to, it is not equal to it's not equal to its previous number. That means it has the number of elements would be same as as middle, whatever this, how should I say it, like we're just counting the count, like is counting the left count. Okay, and now we want to check if this left count is odd or even. If it is odd, then we will choose this left side to basically apply binary search, otherwise we'll choose the right side. So in this case, if left count mod 2 is basically not equal to 0, then we choose left side, and which would be bringing down the right pointer to mid minus 1. Otherwise it will be taking your left pointer to mid plus 1. And at the end, although we don't need this, but I usually end my return with -1 if it's guaranteed, like it's going to return some value. So there will be one answer exactly always. Okay, so let's zoom out and run the code on examples. Okay, examples are passed. Then let's try to submit it. Awesome. Okay, accepted. Now let's write down the time complexity, and it was already asked to us. It needs to be in big of log n time complexity, and binary search is of log n. Space is constant because we're just playing around with the pointers, so that is constant, just like it was asked. Now why is it log n? I have like explained it a lot of time in previous videos, but just remember that each time we are making a decision to basically choose what side, you know, our next number of operations are going to be, and each time, given we have n elements, we are basically deciding which half are we going to choose, and we are doing it every single iteration. So that means if we had n, then next time we are just only trying to work with n by 2, and then n by 4, n by 8, so which means n by 2 to the power 3, and at one point you will just be pointing to one single element, when that will be either your answer or the answer doesn't exist, but in this case it will, and then it will be pointing to basically 1. So that's, so n to the n by 2 to the power k equals to 1, which will basically, if you take 2 to the power k to the right side, it will be big of basically k will equal to log n. If you take log both sides, k comes in the front, and log basically the other side log remains that. Okay, then that's it. Let's go back to AlgoYogi and mark this solved. This was our first medium problem, and we will have around 12-13 problems, or 14-15 problems actually. All right, and after that we will be moving on to dynamic programming and graph. They are the hardest one to get through. Okay, not all, but some, most of them. All right, I'll see you guys in the later videos. Bye bye.